All right, welcome everyone to this lesson on Calico IP address management for Kubernetes. And in this lab, we will look at how Calico IPAM works under the hood. Before we do that, let's look at why IPAM is required for workloads in a Kubernetes cluster. Now, pods, which are the atomic unit for a workload in Kubernetes, are just like any other workload you would encounter, be they your servers, your virtual machines, or even your laptops. Now, these workloads have something called a DHCP server, a dynamic host control protocol server in the network that assigns IPs to these workloads as they come up. Now, a typical DHCP server will not be able to assign IP addresses to pods in Kubernetes. For that, there's something called the IPAM plugin, and Calico is one such IPAM plugin. And the IPAM plugin functionality is typically provided by the CNI. Okay. Now, the plugin is not just responsible for the allocation of IP addresses, but it should do so efficiently to ensure fast pod startup times in the cluster. IP addresses should be assigned in a manner that doesn't conflict with each other. They should also be assigned efficiently, as in the IP address block or the space has to be managed efficiently to facilitate pod-to-pod communication across several nodes or multiple nodes in the Kubernetes cluster. And we will look at how Calico achieves all of this during the hands-on lab. All right, so hopefully you have your lab environment set up. There's a separate video for that. And if you've cloned the repo, in the repo, there's a folder called Container Lab, which includes all the labs we're going to cover as part of this video or learning series. And in that folder, there's a folder called Calico IPAM, which has the files needed for this particular lab. Okay. So in this lab, we're going to provision a 3-node kind cluster using container labs, and the cluster will be deployed with Calico CNI. And we're going to use the 192.168.0.0/16 IP address space to allocate IPs to pods in this cluster. And I will cover what we mean by the block size as we go through the lab. Now, this is what the lab setup looks like. And before I go through this diagram, let's first look at the files in this folder. We have the deploy script. We have the container labs topology file. We have the specification for the kind cluster and the custom resources, which is essentially the configuration for Calico CNI. Okay. Next, let's go through each of these files one by one. So if I go through the container lab topology, this is a pretty straightforward one. In this topology, we have the kind clusters and we have the startup config for the kind cluster. Next, let's look at that config. So the kind cluster will be deployed without the default CNI, and that's because we will be installing Calico CNI once the cluster is provisioned. And in this cluster, we've specified the pod subnet to be 192.168.0.0/16. Now there's a service subnet as well, which we've not covered yet. I am gonna skip the explanation for this and we will cover this in a subsequent lab. And this cluster is gonna have 3 nodes, 1 control plane node and 2 worker nodes, okay? So in this diagram here, this is the definition of the kind cluster. And the important thing to note here is that we've defined the pod subnet to be the 192.168 CIDR. Next, let's look at the Calico configuration. So I'm going to open the custom. So let me navigate to that folder first, and let's open the custom resources.yaml file. And the important thing to note is in this YAML file, there is a resource called installation. And in the installation resource, we provide the specification for the Calico install. And in this case, we are configuring or defining something known as an IP pool. And in this IP pool, we've configured the CIDR to be 192.168.0.0/16. Okay. Now, the important thing to note here is that the pod subnet in the kind cluster, or in any Kubernetes cluster for that matter, the pod CIDR should match the IP pool CIDR that you configure in Calico. Okay, there are some issues if it doesn't match. I will go through those issues when we look at pod networking. But the important thing for this lab is to ensure that these values match the pod subnet in the kind cluster configuration or any Kubernetes cluster configuration with the CIDR that you define for the Calico IP pool. Okay. And the second resource here is the Calico API server. We have it with its default configuration. So a very minimal Calico install. The important thing to note is the configuration of this installation resource, with the IP pool that has the correct pod CIDR. I'm not going to cover the rest of the parameters. We will look at those parameters as we look at pod networking and pod routing in subsequent labs of this series. We have one more parameter here called the block size, and I'll cover this as we go through the lab. Okay. So in this lab, as we run the deploy script, it's going to first provision this client cluster. And once it comes up, deploy Calico. And then we will look at how Calico takes this IP block or IP address space rather than assigns IP blocks to individual nodes in the cluster. Okay. Okay. So in the lab, feel free to follow along. If you're in this folder, we have the deploy script. So the first thing you have to do is make that script an executable and run the deploy script that will provision the container lab topology with the kind cluster and then install Calico CNI. Now, as this runs, what we can do is quickly review that script. It's pretty straightforward. What it does is provision the container lab topology. Okay, so we've got the container lab deploy command to do so. And once the cluster is up and running, we retrieve the kubeconfig file, set that as an environment variable, and then install calicoctl, which is a tool that we will use in our terminal to verify certain configurations. The kubeconfig file is not required for calicoctl. It is, however, required for the Calico install that the script goes through next. Once the Calico install is complete, the script will make sure that the Calico API server is available and also that the Calico components are up and running. Okay. So yeah, it's a pretty straightforward script. Essentially, install Calico CNI on top of this kind cluster. So now we can see the kind cluster is up and running, and the script is waiting for it to be ready and waiting for the kubeconfig file to be available, and it'll then progress towards installing Calico. Right, so we see the Calico custom resources were installed, and now it's waiting for Calico components to be ready. All right, and there you have it. We have the cluster up and running. The Tigera status command indicates that all Calico components are in an available state. So let's go back to the lab here. All right, so one of the first things I like to do once the container lab topology has been provisioned is to inspect it, and you could do so using the container lab inspect command. So let me copy this and run it for this cluster. So we see that we have a 3-node kind cluster that has been deployed, 1 control plane node and 2 worker nodes. We can see the image that's been used for this cluster, the state of these nodes, as well as the IP addresses of the containers that were provisioned for this cluster. Now with Container Lab, bear in mind that these nodes are actually containers in this particular host of ours. Okay. All right, so with the cluster up and running, what the deploy script does is it also spits out a kubeconfig file. So let's set it up as an environment variable. And once we do so, we can run commands such as kubectl get Tigera status to look at the availability of Calico components, and we see that all components are available, they're up and running. And you can also issue commands such as kubectl get nodes. We see the 3 nodes of this kind cluster, and if I do a kubectl get nodes dash o wide, we can also see the IP addresses of those nodes, which align with the IP addresses that we saw as part of the container lab topology output. Okay, so our cluster is up and running. So if we go through the lab, so next let's run this particular command, calicoctl IPAM show. And this command is going to output the CIDR range that we've allocated for this cluster. If you remember, this was specified both in the pod CIDR spec in the kind cluster manifest, as well as in the IP pool resource we configured for Calico. So this IP block provides us a total of 65,000 plus IP addresses, and currently we have 12 IPs in use and this many IPs that are available for this cluster. So this command can be used to look at the utilization of your IP address space for a given Kubernetes cluster. Okay. Now, if I do a kubectl get pods, right? Let me say dash a. You probably see that we have more than 12 pods in this cluster. So in this particular cluster, probably have about 22 pods. So why is it that we're using only 12 IP addresses? Now, an important thing to bear in mind is, and for this, let me just expand my terminal a bit, and let's do a kubectl get pods dash a dash o wide. As you look at a Kubernetes cluster, you're going to notice some pods that have IP addresses from the IP address space that you've specified. So for example, if you look at the Calico API server pods here, those have IPs in the 192.168 range, which is the range that you've specified as the pod CIDR range. But in the cluster, you're going to have certain control plane components that utilize or leverage what we call the host network. So in this cluster, if I look at pods, for example, if I look at etcd or the Kube API server, I'm going to notice that those pods have a 172 IP, which is the IPs of the node. And in fact, in this case, if I do a kubectl get nodes dash o wide, so etcd in this case is scheduled in the control plane node, and we see that that pod has an IP that corresponds with the IP of the node, right? Now, similarly, we see Calico node pods utilizing the IPs of the node, right? So what this means is these pods, and especially, and this applies to critical pods in the cluster, they leverage or utilize the host interface, right? So if you look at a node in the cluster, you have what we call the pod network, which is this one over here. And if you take a typical pod, it's going to have an interface. This pod is going to have a separate pod network namespace, and it's going to have an interface for which an IP will be assigned by the IPAM plugin, Calico in this case. But then you're going to have some other pods. So for example, if you take something like etcd, it's going to have an interface attached to the host network namespace, and it's going to be using the host interface in this case, right? And that's why you see it having an IP address or having the same IP address as the hosts or nodes interface, right? Now, the reason for this is if you look at these type of pods, given that they are critical, because the pod network is not something that need be available for a cluster to function, right? So for some reason, if your pod network is not up and running, a cluster or the control plane components are still available, and that's because they utilize the host interface or the host network. Okay. So that's the reason, for that discrepancy, if you've ever, wondered. So in this cluster, we have 12 pods that are using the pod network for which Calico has assigned IPs. Okay. All right. So next we have something called, so let me just remove those markings. So next we have something called block affinities, right? Now, a block affinity is a resource. It's a Kubernetes resource that represents an IP block assigned to nodes. Okay. So let's double click on this a bit. So I'm going to go to one of these diagrams. Now, we provision the cluster, we configure a Calico IP pool resource. So what Calico does is it's going to next take that resource and configure or create what are known as IP blocks that belong to this IP address space, right? So it's going to carve out smaller blocks from that address space, and it's going to allocate those blocks to nodes in the cluster. Now, the objective of this is so that when a pod comes up, this node already has a pre-allocated block, and the pod receives an IP, from that pre-allocated block. Now, as IP addresses run out, so let's say, if IPs of this block run out, something like a /26 block in this case would provide about 64 IP addresses. And if you have more than 64 pods in this node, Calico will assign another IP block for that node or for that host in the cluster. Okay. So those IP block assignments are represented as block affinities. So if you do a kubectl get block affinities, given that we have 3 nodes in this cluster, we see 3 block affinities. And if you want to look at, so before I go there, if you look at the naming convention for these block affinities, so you're going to say Calico IPAM control plane, which is the name of the node, and then that's going to be suffixed with the IP block. Okay, so this is a 192.168.18.64/26 IP block. Now what we can also do is run this command to get a detailed output of those block affinities. So you can see the block that was created and the node to which that block has been assigned, and the state of the block. So a confirmed state indicates that the block is being actively used. That could be a pending state as well, which means the block is in the process of being assigned to a node. Okay. All right, so we looked at the concept of, block affinities and how Calico creates those affinities and assigns them to nodes in the cluster. Now, if you need a more concise output, you could run this command, and that's going to give you the name of the affinity, the node to which it's assigned, and the IP block that was assigned. So let me just run that command again, and that's what the output looks like. Okay. All right. So, there you have it. We covered how Calico assigns IP addresses to pods in a Kubernetes cluster, and we went through some commands as well. And you could use these commands in your environment to troubleshoot IP address assignment issue, or just to understand, how IP addresses are assigned to pods in your Kubernetes cluster, right? So the key concepts that we covered in this lab were IP pools. We looked at how IP pools are configured in Calico. We looked at how IP blocks are created, and how those blocks are assigned to nodes in the cluster. All right. And, pods are given IP addresses from those blocks as they come up. All right. So in this lab guide, there are a few troubleshooting commands as well. And I think what I'll do is also add a link to the Calico docs page that has a few more advanced IPAM commands that are available to troubleshoot issues that you could encounter, with IPAM. And I may cover that even in a subsequent advanced lesson. So that's it for this video. Now, if you want to clean up this lab, just run the destroy script, and that should clean up the kind cluster. So I hope you found this to be useful. So we covered IPAM, and next we're going to cover pod networking and pod routing. So I'll see you in those lessons. Thanks for watching and have a good rest of the day. Bye for now.